those who, our oil is waxy, so it does not flow at room temperature. We need to heat it for it to be able to flow. And so the EACOP pipeline is a heat-stressed pipeline. We have to introduce heat so that the oil continues to flow. Let's move on. So this is a schematic of, similar to the other one, Tilenga, Kingfisher. The oil arrives here at PS1. At PS1, the oil can either go to the East African Crude Oil Pipeline or to the refinery, which is just adjacent to PS1. Yeah? So we have allocation meters, and then we have this is a fiscal meter. Fiscal meter into EACOP, fiscal meter into the refinery. Okay? So for EACOP, we talked about pumping station 1, which is here, pumping station 2. Then we will have the oil flow all the way to the tanks and Indian Ocean. Along this route, we have other things. Okay? We have block valves. For instance, in Uganda we have 23 main block valves. So these valves, we can be able to isolate sections of the pipeline remotely. We will control the pipeline from Uganda and also from Tanga. Yeah? So, for instance, across Katonga River, yeah? If there is any incident, we can isolate that section and do work. For environmental issues, because the oil is waxy, it does not flow. The moment it comes out 50 degrees to the 27, it will not flow for a long time. But we should be able to, because these pumps are powerful. Yeah? If you're pushing 230,000 barrels per day, yeah? You should be able to stop, close the main block valves and control immediately. So along that, we will see on the next slide, we also have a fiber optic cable that has been laid with the pipe. So the pipes come, it's steel. It is coated with fusion bonding epoxy to again help with corrosion. Yeah? Then to heat the pipe and the oil, yeah, so that it can flow, we have heat tracing systems. We have 3 raceways through which electrical cables pass, just like a coil for the flat iron. Yeah? This will heat that and then keep the oil to temperature above 50 where it flows. Then the pipe is buried, like you can see. This is roughly 1.6 to 1.8 meters, but in certain cases we even go 20 meters below. Yeah? Below the ground, like where the rivers, we cannot go just 1 meter below the riverbed. So this is minimum. Then after the fusion bonding epoxy, to ensure that we do not lose heat to the environment, we have foam around the pipe. Yeah. There is a foam, this polyurethane foam, and this foam is just like what we have in mattresses, yeah? But specialized foam. So you cannot lay a pipe with that foam; it will get damaged. So we put on top of the foam, we put heavy density polyethylene. This black, yeah, around 5 to 8 millimeters thick. Yeah, and it depends on where. Even the pipe itself is how many inches? We're talking about 24-inch, but it also depends. The thickness of the pipe depends on where the pipe is going to be placed. If it's a fault zone, you need a thicker pipe. If you're going under a national road, you may need a slightly thicker pipe. Yeah. So this is this fiber optic cable. So this one we've considered it the longest. It's like a thermos flask. You know, the longest thermos flask in the world. Yeah, today. Yeah. So just like your flask, when it's at 100 degrees Celsius, it has water in there at 100 degrees Celsius. When you touch it. So whatever people are saying that the pipe is heated and it's now burning the environment, it's not true. Yeah? It's a thermos flask, yeah? But an intelligent thermos flask. Fiber optic cable, the 96 detect several things, including vibrations, including intrusion. If you opened up this, because the pipe is buried, it will detect that the temperatures are changing. And this can be detected from Tanga and in Uganda immediately. If there are cows, if it's a bus, the system can detect exactly what is happening. If there's a leakage and the oil came out, and we're working so hard to have our ready for oil export in January 2027. What we have here, pipes have been welded, almost 99% that the entire pipe has been welded. There's backfilling, we've had almost all crossings done. Today we've lowered close to 98% of the pipe is lowered. You will see in the next, that today, in most cases you will not see the pipe. In fact, we've started reinstating and revegetating. So we can move. So this is PS1. We have a 360-degree picture that we'd like to show you. This area here, you're saying between that and this side is the process area. This is where the oil is. This is where the oil flows. This is where the pumps are. This is where the drug reducing agent injection kits are. Everything is here. Yeah? Chilenga is coming in from the north. Yeah? This is where the Chilenga pipeline is coming in. It's already buried. Yeah? And then it comes in into this area. This is the Chilenga receiver. Yeah? The pig receiver. Then Kingfisher will come in from that side. Yeah? That is true north. Yeah? It will come in from that side and then come here. This is the Kingfisher receiver. The Kingfisher line. Yeah? By the way, just as we are here, the refinery, this is the refinery line, just above. Yes. Yeah? So, when the oil comes in here, the allocation meters, everything, we have the metering system. You have the 3 pumps already installed. These ones are the export pumps that we will. So the EACOP line, this is the EACOP, this is the Chilenga receiver, this is the EACOP launcher. So EACOP launches and still through the same corridor, but for it will go south instead. Okay? So this has already been worked on. We are making sure that the process area is complete, ready for startup in Uganda. We're looking at end of October. Then that is the first section. The next section, which is because that's just oil and but then here that's the second part. So you cannot, now that we're saying it's electrically heated. We're talking about high voltage cables running along the pipeline. We need to manage even the pumps. So this section is has electricity, it has transformers, it has the EACOP building, it has variable speed drives, and dedicated transformers for the pumps. And it also has observation basin where oily water, if it has gone through the open drainage, we observe from there before pumping back the water. Yeah. And the last section, which is the administrative building, the workshop areas, those are closer. They are further from the oil. Yeah? Normally, you do not put oil close to people. Yeah? So we have an office building. There's going to be accommodation here. We have a workshop area. We have chemical storage tanks. And finally, what we also have, this is it's an electrical. This receives power from the KIP substation, or UETCL substation. Because in Uganda, we are heating the line using 100% grid. So the grid from the substation, which is 2 kilometers from here, this is where the power comes through. Then to the EAGS building, and then it manages everything between here and Mr. Okay. So so when we look at the pumping stations, we look at pipe welding, concrete achievements, steel structure erection, hydro test. the civil and steel structure progress. Then this is where we have mechanical progress, and most especially the plant management. And then the EAT progress. Cabling, we put a lot of cables and termination. So when we look at all that, each site has a different progress. Yeah? But all the sites we are looking at above, we're in 80s. Okay, so PS1 progress is 85% right now. We can move on. PS2, which is a little bit smaller, it is in Sembabule. It's okay. Yeah, this is PS2 again. The pipe. It's the same philosophy. The pipe will come in from the other side and then go out. But so this is the right of way. You can see the right of way. The rate statement is already. You may not notice it after a few more months. Yeah? The pipe is already buried here. It comes in. There is a receiver here and a launcher. And again, this is the process area. We have the process area. We also have 3 export pumps. Yeah? If you go up, all that is managed by an EATS building. Yeah? Again with transformers. Here, the EACOP pipeline is 1,443 kilometers long. However, when you look at our statistics, we're talking about 1,500. Close to 1,543 kilometers. Why the difference? Because we have EACOP Limited is also handling the Tilenga feeder line, which is around 96 kilometers. Yeah. And this progress is everything. So if the pipe was 1,543 up to that point, we have buried, lowered already 1,514. The HV cables, close to 1,273 cables have been installed. They move along the line. And when we bury the pipeline, we also put the fiber optic cable. Yeah. Then the right of way is being reinstated, and you'll see some photos. Yeah. Key. After the pipe, we have sections of the pipe. There were each pipe was 18 meters long. Yeah. So we had to add these 18-meter long pipes. But when we are doing the hydro testing, we had to get sections, probably a 60-kilometer section and hydro test. Yeah. After you hydro tested this section of several pipes joined together, you're sure that each of those welds is the integrity is okay. But what happens between sections? Yeah? So between sections, when we join the 2 hydro test sections, we cannot again do the hydro testing. We call them golden drains. Yeah? And we do special management of those golden drains. The way when you do the NDTs, the tests, the PUTs, all these tests on a golden drain, they are much more than the normal drains that are going to be hydro tested. Okay? So we've so far done 36, 39, close to 40% golden drain. I talked about the block valves. You can see the valves are being installed. The equipment containers, those are the ML building. Each ML building has a container that manages the valves. Yes. These have also been installed, and hydro test is going on. So a lot of very good progress.
The CPS that is ready, what CPS that will be ready to bring on board is that one. Vis-a-vis the pipeline of 230. That's clarification 1. The other, I'm looking at the local content. It's good we have the basic numbers of our locals who are involved. But 2 things that don't seem to come out clearly for if I were to appreciate further, what is the composition, or do you disaggregate male and female, or it is just local and foreign? 2, for the local, what is the actual value of money that goes to the locals as a percentage of what is going or what is being paid out. Because we might be having numbers of 3,000 or so, but getting like 10% of what the others are getting. So what is it? Because that really will speak into the actual value that is being retained by the locals. And finally, I think there was something about hitting the pipeline, where we chose Uganda 100% is by power. Although in the explanation somewhere we say there is plan B in the event or so. But what formed the basis for choosing power? Is it because it is reliable? Is it because it is cheap? Is it because it's a combination? And what is happening on the other side, Tanzania, in the comparison? Are they also using hydropower or something like that?
The assessment of the impact of the end of this project, what will happen to these families and the community that has been depending on this income, which income is compared to the other economic activities, this is highly important for them. So has there been any study, and therefore to give them a soft landing? Then too, now that the project is ending, is there any specific competence that the country is getting that can be later transferred? Because most of the technical work has been done by foreigners, I guess. Can we be confident that now Uganda can do something maybe as part of that capacity that we can transfer in the region? Do we have a profile of that? That competence as a country?
Last question.